DeepSeek just open sourced something that, at first glance, looks like another Claude Code competitor. It already has more than 160,000 stars on GitHub. There's a web interface, it can read your code, use tools, run commands, switch models, and work through coding tasks. So you might look at this and think, okay, DeepSeek made its own Claude Code, but that's actually the least interesting part of this project. Because with Claude Code Codex or most other coding agents, you mainly customize what the agent can do. You add an MCP server, you install a skill, you create a hook, you give it another tool. DeepSeek Harness goes one layer lower. Here, you can change how the agent itself works. The model adapter is replaceable. The tool registry is replaceable. The session system is replaceable. Even the actual agent loop, the thing deciding when the model thinks, calls a tool, reads the result, and continues, is replaceable. DeepSeek calls this, everything is a plugin. And strangely enough, this isn't really marketing. They mean it almost literally. So I wanted to understand what DeepSeek actually built here, why developers are suddenly so interested in it, and whether this is something you should actually use instead of Claude Code or Codex. Because there is one very interesting idea hidden underneath this repo. And there's also one pretty serious catch. Getting it running is surprisingly simple. Assuming you already have Node installed, you can run npx at DeepSeek AI DSH web. And that starts the interface locally by default on port 3080. The UI itself isn't revolutionary. You have your workspace, conversations, model configuration, permissions, different agent presets, and the usual prompt box. If you've used modern coding agents before, none of this should feel particularly strange. And that's important, because the interface is not really the product. The interesting part is what is underneath it. Think about an AI coding agent like a car. The language model is the engine. Claude, GPT, DeepSeek, whatever model you're using. But the engine doesn't decide everything. Something has to decide what files the model sees, what tools it gets, when it calls those tools, how the results come back, how context is compressed, what happens when a command fails, when the agent should continue, and when it should stop. That entire system around the model is the harness, and we've already seen how important that layer can be. Two coding agents can use exactly the same model and still behave completely differently because their context management, tool usage, and agent loops are different. DeepSeek Harness basically says, what if you could modify that layer too? Underneath DSH is a framework called Cordis, and instead of building one giant application with a fixed core, Cordis lets the harness boot as a tree of components. DeepSeek's own documentation says there is no privileged core that you have to patch. Instead, components register themselves into a shared context, and those components can be replaced through configuration. This means something surprisingly fundamental. Adding a new search tool and changing the actual agent loop are technically different levels of the same plugin system. That's very different from how most people think about plugins. Normally, a plugin means, here's one extra capability. Maybe now Claude can access Jira or search documentation or query a database. But imagine telling your coding agent, whenever a test fails, don't immediately send the entire result back to the model. Extract only the failing tests, the relevant stack trace, and the changed files. Then retry using that smaller context. That is not simply giving the model another tool. You are changing the behavior of the harness itself. Or maybe you want a different agent that performs 3 independent code searches in parallel before making its first edit. Again, that's harness behavior. And this is where DeepSeek Harness starts getting interesting. You can actually inspect the composition that's being loaded by running a command like dsh profile web dump config. And what you see isn't just one application called DeepSeek Harness. You effectively see the pieces that create it. The base layer provides things like model adapters, tools, persistence, credentials, sandboxing, and approvals. Another layer adds the web application. You can then apply your own configuration or plugins on top. So when DeepSeek says everything is a plugin, the architecture actually backs that up. But there is another feature here that I think might be even more useful than the plugin system, and it gets far less attention. Observability. Coding agents are becoming increasingly autonomous, which creates a really annoying problem. When an agent does something stupid, why did it do it? Maybe the model misunderstood your instruction. Maybe an old message was still inside the context. Maybe a tool returned bad information. Maybe some hidden system prompt changed its behavior. Maybe the agent searched the wrong file and everything after that was based on a false assumption. Normally, debugging this can feel like forensic science. DeepSeek Harness takes a very different approach. Its session system is built around an append-only event log, and the documentation contains one sentence that explains the philosophy extremely well. Model visible means logged. In other words, If something reaches the model, the system should be able to reconstruct it from the session log. A turn begins. The user's message enters. The system prompt and tool definitions are assembled. A model request happens. The assistant starts streaming. Maybe it calls a tool. That tool call gets recorded. The tool result gets recorded. Then another model step might happen. And eventually the turn ends. Those events become a durable history of what the agent actually did. That's why the interface can expose things like the trajectory of a run. Instead of only seeing, I changed 3 files, you can inspect the path it took to get there: user input, injected context, assistant output, tool calls, tool results. And this architecture also makes things like replay, resume, transcripts, and telemetry much easier to build. For normal users, that might sound like unnecessary internal plumbing, but once you're running agents on larger repositories or letting them execute longer tasks, this becomes incredibly valuable. Because eventually the question stops being, can the agent write code? And becomes, can I understand why it wrote this code? Now there is another interesting idea in the interface: creator mode. This is probably the feature that creates the most futuristic version of this project. Instead of manually writing every customization yourself, the idea is that the agent can help create plugins that modify its own environment. You could ask for a new interface component, a custom tool, or potentially a workflow designed specifically around the way your team works. And because so much of the underlying system is exposed through plugin boundaries, the theoretical endpoint is pretty wild. Your coding agent doesn't just adapt its answer to the task, it adapts its harness to the task. But I would be careful with calling this a self-improving agent. We're not really watching an AI recursively redesign itself into a better intelligence. It's much closer to an agent generating software that changes the environment it operates inside. Still powerful, just much less magical than it sounds. And customizability creates another problem: trust. This is probably the biggest caveat with the entire everything is a plugin idea. DeepSeek Harness now includes sandbox and approval mechanisms for agent tool execution. For example, shell execution and file system capabilities can be routed through guarded execution policies. That's good, but that does not mean every random third-party plugin you find online suddenly becomes safe. These are 2 different trust boundaries. An agent running a shell command inside a sandbox is one thing. Installing code into the harness itself is another. A third-party plugin should be treated much more like installing an NPM dependency than installing a harmless theme. You're executing someone else's code inside an extremely powerful developer tool, a tool that potentially has access to your repository, credentials, and development environment. So if the ecosystem around DSH explodes with plugins, this is the part I would pay very close attention to. Everything is a plugin is an amazing extensibility model, but it's also a supply chain security problem waiting to happen if people blindly copy install commands from random GitHub repos. There's also one other claim you should understand correctly: DeepSeek Harness can run locally. That does not automatically mean your AI is local. The web UI and harness can be running on your computer while the actual inference is happening through DeepSeek's API or another remote provider. Those are 2 completely different things. The architecture makes the model layer replaceable, which is great. But if you're using OpenRouter, DeepSeek's API, or another cloud provider, your prompts are still leaving your machine. Local harness does not mean local inference. And I think that's actually a good example of why this project is interesting. Because DeepSeek Harness isn't really tied to DeepSeek in the way its name suggests, the model is only one component. You can replace that component while keeping the rest of the system. Which brings us to the obvious question: should you stop using Claude Code or Codex and switch to this? Right now? Probably not. And I don't think that's actually the right comparison. If what you want is open terminal, give agent task, agent writes code. Claude Code and Codex are already extremely polished ways to do that. DeepSeek Harness is still explicitly labeled a developer preview. DeepSeek warns that compatibility breaking changes will happen, and most developers probably don't need to replace their agent loop. But if you're interested in building agent infrastructure, experimenting with different context strategies, creating custom execution policies, changing how tools interact with the model, or simply understanding exactly what an autonomous coding agent is doing, then this repo is much more interesting. Because DeepSeek didn't just open source another coding assistant, they open sourced a large part of the machinery around the assistant. And I think that's the bigger idea here. For the last few years, almost every AI discussion has been about models. Which model has the best benchmark? Which model has more context? Which model is cheaper? But as models become increasingly similar in capability, the harness around those models starts mattering more. What context do you give them? What tools? What memory? What execution environment? what retry logic, what verification, and how much of that system can you actually control? DeepSeek Harness pushes that question unusually far. So I wouldn't look at this repo and ask, is this the Claude Code killer? I would ask something much more interesting. What happens when the coding agent itself becomes programmable? Because DeepSeek Harness might not be the tool everyone switches to, but the idea behind it could end up becoming much bigger than the tool itself.